Welcome everyone. In this video, we are going to solve another problem related to force vectors, which is second chapter in the book of Engineering Mechanics, the statics part by R.C. Hibbeler. The audio of this video is available in different languages. You can simply change the audio track by going into the setting button at bottom right corner. You can listen this video in Hindi, Spanish, Portuguese, German, Japanese, and Indonesian languages. So in this video, we are being asked to determine the resultant force and also its orientation because of three different forces which are acting at point A. That point is actually in the femur, and these forces are due to the three different muscles, and those muscles are connected with pelvis B. So this is pelvis and this is femur. Because of the three different muscles, there are three different forces are there, and we are being asked to determine the resultant of these three forces and also its orientation measured counterclockwise from positive x-axis. So let's solve this problem considering the same pelvis and femur as the forces are acting at point A. So we will show x and y axis at point A, and then we will apply forces and we will determine the resultant. Now in this case, which is quite different from the previous cases, in previous cases we usually being given with two forces only, but here there are three forces are there. So when we had two forces, simply using cosine law, we have determined the resultant, the magnitude of the resultant, and their orientation using sine law. But we cannot directly apply cosine law or sine law when there are three forces up here. But we can do like this, like we can choose any two forces first, and we will determine their resultant. Then those two forces will be converted to a resultant. Now that resultant and the third force will be the two forces then, and using again cosine law we can determine the resultant and sine law for their orientation. Now what do I mean by that? Let's take first two forces. Let's say I'm taking the 60 Newton force and 80 Newton force. I'll first determine the resultant of these two forces and also the orientation of that resultant. So using cosine law, we know that the resultant, which will not be actually the total resultant of these three forces, but the resultant of two forces, let's name that as F or 1, will be calculated using this formula where the two forces 60 and 80 Newton will be used. Now the 260 multiplied by 80 and then cosine of, let's say, alpha. Now what's alpha here? The alpha is actually the angle between these two forces. We are not directly being given with that angle, but we know this angle is 30. So in order to have the total angle between x and y as 90, this angle should be 60 degrees. So the angle between them is actually 60 degrees. So instead of alpha, we'll just write 60 degrees here. So then on doing calculations, we are going to get the resultant of these two forces as 121.66 Newton as the resultant. Now for the direction, we should use the sine law. For that, we should form a triangle first. So I'll keep the 80 Newton force at the same position, and I will drag the 60 Newton force using the tail of the 60 Newton and head of the 80 Newton force like this way. So then the closing side would be the resultant that we just have calculated as 121.66 Newton. Now we want this angle using sine law, if you remember. Since we are interested in determining the angle or the orientation of the resultant force of these two forces, so that will be actually this interior angle in this triangle. In this triangle, we can have one known angle, which could be this one. Obviously, this cannot be because we are not sure with the angle of the resultant, but we can determine this interior angle because we are known with the orientation of these two forces. So if I consider this as a parallel line, if this is 30, this should also be 30 because the opposite angles should be same in a parallel two lines and cutting a one line cutting through that. This is 30 actually, and this is x axis and this is y axis, so this will be 90. This angle is actually 90. So if you add 30 and 90, it will become 120. So this interior angle is 120. So I use sine 120 divided by the magnitude of the force of the opposite side. In this case is actually the resultant, which is 121.66. This should be equal to the angle of our interest, which is, let's say, this one. So I name that as a beta. So that sine beta would be divided with the opposite side, which is 60 Newton here. So divide by 60. Now from here we can have the angle of beta using the simple calculations. So on doing calculations, you are going to get 25.28 degrees actually. Now this is FR1. Now we can use the third force, which we haven't used before, which is 120 Newton. And using this FR1 and 120 Newton force, we can determine their resultant. So that resultant will be the total resultant of these three forces. And then we can determine the orientation of that force as well, the resultant. So let's go for that. Now taking the third force, which is 120 Newton. Since an angle is not given, but we can determine this angle using this triangle. So this angle would be the same as that of this angle. So using the tan inverse formula, because we know each other side of this right angle triangle, simply dividing the perpendicular with the base, we can determine the tan inverse. And on doing calculations, we are going to get 67.38 as the angle of this force. It means this angle is 67.38 degrees. We have the resultant from the 80 Newton and 60 Newton force, which was over here, and that had the magnitude of 121.66 Newton. We were given with its orientation, not directly but indirectly. We have determined the interior angle, which was 25.28, and there was, if you see from the back side, you can see the total angle this FR1 resultant will be making would be this one with the positive x-axis. So this beta came out to be 25.28. So this total angle from the positive x-axis will be actually 55.28 degrees. So then we can simply write as this angle as 55.28 degrees. Now since we have the direction of both these forces, 120 Newton force and FR1 force, now we can determine the magnitude of the resultant force using cosine law. So using cosine law, the resultant force would be equal to, in under root, 120 square plus 1 to 1.66 square plus 2 120 121.66 cos the angle between these two forces. I mean this angle. So this angle can be simply calculated by subtracting 55.28 from 67.38. So this angle would be then 12.1 degrees. So 12.1 degrees. Now we can determine the magnitude of the resultant force. So the magnitude of the resultant force would be 240.31 Newton. So we are successful in determining the resultant force caused by these three forces. The next thing is we want to know its orientation as well. For that, again, we are going to use the sine law. Now this force is actually FR1 that has magnitude of 121.66 Newton. It has angle of 55.28 degrees. We have 120 Newton force to be placed on the head of the first force, which in this case I choose to be FR1, and this makes an angle of 66.38 degrees. The closing side would be the resultant, which we just have calculated as 240.31 Newton. If we are interested in determining its orientation, means this interior angle first, and then we will add 55.28 in order to have the orientation with respect to positive x-axis. So this angle is of our interest. Let's say this angle is gamma. So sine gamma divide by the magnitude of the opposite side, which is 120. Now, in this triangle, the only angle which we can determine is this angle. So this angle will be, we need to do a bit of geometry here. So if this angle is 55.28, so this opposite angle will also be 55.28, because there are two parallel lines there and there's a third line cutting, so opposite angles would be same. So 55.28, this will also be 55.28. And this total angle from here to here will be 180. So if we subtract 66.38 from 120, then we can determine this angle. So 55.28, which is this angle, to be added with this angle from here to here. So this can be determined by simply subtracting 66.38 from 128 degrees. So simplifying this, we are going to get the angle between these two forces, the FR1 and 120 Newton, as 167.90 degrees as this angle. So sine of 167.90 divided by the magnitude of the opposite side, which is 240.31. Simply put 240.31. So from here we can have the magnitude of gamma as 6.01 degrees. Now this angle is actually 6.01 degrees, but we are being asked to determine the orientation of resultant, which is theta, from the positive x-axis. So simply we need to add 6.01 with 55.28, then we can have the angle from positive x-axis. So 55.28 plus 6.01, so it will make 61.3 degrees. This will be that another answer. So now we have determined the magnitude of the resultant force caused by these three forces, which came out to be 240.31 Newton force. The orientation of the resultant force from the positive x-axis, which we also determined, that is 61.3 degrees. So this is what being asked to us. We did it through the cosine law and the sine law. However, there would be many other ways through which you can determine, but this is one of the procedure to do it. I believe you could understand how I did all these calculations, but obviously there is some things could be there which you may not get grasp of that. If you are juggling somewhere, please let me know through the comment section so that I can get back to you. That's all from this video. Thank you for watching this video. I hope to see you in next coming videos. Till then, bye.